All right, so systems of equations. Let's do these problems. Okay, so are we starting on 1?
Yeah.
Okay, so is 4 2 a solution? Well, if this is a solution, then that would mean when you plug 4 in for x and 2 in for y for both of those equations, it will be a true equation.
Okay.
So if I plug in 4 for x here and 2 for y, does that equal 14?
Yes.
Sure does. If I plug in 4 for x and 2 for y, does that equal 12?
Hang on, wait, let me do that.
That would be 8 minus 4. Does 8 minus 4 equal 12?
No.
No. So this is not a solution to the system. It's a solution to one of the equations, which means it's a point on the line, but it's not a solution to the system because it's not a point that satisfies both equations.
Yeah.
So like those equations would be like 2 lines, something like this.
Okay.
And that point was right here. It was on one line, but it wasn't on the other line. The only one that's the solution to the system is where they intersect, which is that point. Okay.
Okay.
For number 2, it says identify the number of solutions. Well, the answer is either going to be 0, 1, or an infinite number, right? Those are your 3 options.
Yeah.
And the way you find out, the easiest way, if you ask me, is to put them both in slope-intercept form. Since one of them already is, let's convert this other one to slope-intercept form. Y equals negative 3x plus 10. See how I did that?
Yeah. Okay.
And do you see how the slopes are the same, but the y-intercepts are different, which means they are what?
One solution?
The slopes are the same, negative 3, but the y-intercepts are different. One of them is at 10, negative 3, so it's like this. And the other one goes through negative 5, negative 3. So it's like this. But the slopes are the same, which means they're never going to intersect.
Oh, no solution?
That's right. There's no solution.
Okay.
You understand how I did that?
Yeah.
Slopes are the same, which means that they're either no solutions or an infinite number of solutions when the slopes are the same.
Yeah.
The reason it would be infinite is that they were the exact same line. One was on the other one.
Yeah.
But that's not the case. These are 2 parallel lines. Slopes are the same. Y-intercepts are different. That means they're parallel. So your answer is no solution.
Okay.
All right.
Yeah.
Number 3 says solve by graphing. All right. So we're going to graph these equations. I'll do this one in white. So what's the best way to graph an equation that's in slope-intercept form like this?
Plot the slope-intercept first.
So tell me what the slope-intercept is.
For the top one, it's negative 3.
Good. So you meant y-intercept. You meant y-intercept.
Oh, yeah.
Good. Yep. So the y-intercept's negative 3, and then what?
And then you plot the negative 1.
No, let's not do that yet. These are 2 different lines. Let's graph the first line first with the white, and then I'll graph the second line with yellow.
Okay. And then you would take the 2x and then like put a 1 under it for the slope, and then you'd go up.
Do you mean 2x?
Yeah.
Or just 2?
No, under the 2x.
Right. Well, let's just do this. Let's call m is 2 over 1. That's what you mean, right?
Yeah.
The slope is 2 over 1. So what do I do?
You go up 2 over 1.
From here?
From negative 3.
From the point. That's right. I go up 2 and over 1. And that'll give me another point. And I can keep doing that, in fact, if I want.
Yeah.
Just to make sure I draw my line correctly. And then I can go down 2 into the left one, right?
Yeah.
Good. So there's my line. There's my line.
Okay.
Okay, how about the yellow one? Where do I start?
You plot your point at -1.
Good. Right here?
No, on the y-axis.
Good. Just checking. And then what?
Yep. And then would that just be considered a 1?
Mm-hmm.
Okay, and then from there, you'd go just up 1 over 1.
Good.
From the -1 point.
And then continue, right?
Yeah, and then they'd intersect at 2, 1, or 2, 1.
Perfect. I didn't draw that great, but yes, you're right. They're going to intersect at 2, 1.
Okay.
2, 1. So that's your solution. Good. Now, what's the best way to graph these equations over here? Since they're not in slope-intercept form, have I taught you this little trick? There's a couple ways you can do it. One thing you could do is just solve them for y, because it seems like you have a pretty good grasp on this. You could just solve each one of them for y, and then graph them this way, the way you did these lines. The other way is where which would work nicely for this example, is you would do what I call the cover-up method. What you're doing is you want to find 2 points, and the points you want to find are the intercepts. So you plug 0 in for x, and then you plug 0 in for y separately. Two different steps. You first find the y-intercept, plug 0 in for x to find the y-intercept. So plugging 0 in for x means this is gone. And what does y equal?
6.
Good. See how easy that was?
Yeah.
So 0, 6 is one of your points. And now let's do the same thing, but for the x-intercept now. Plug 0 in for y, which means this is gone. Do that in your head real quick.
-2?
Solve it for x, not -2.
Oh, the top equation. Okay. Just 2.
+2.
Yeah.
So 2, 0. Hey, there we go. And now you want to be careful and draw your line as straight as you possibly can between those 2 points, because we might not be able to find the solution if it's not nice and straight. I'm using a credit card to do this. Oh, that was ugly. Try that again. It's not great on an iPad to try to do this.
Yeah.
Well, that's better. Okay, there's the white line. And now let's find the yellow line. Let me see if you want to try that one. Try to do that little trick I told you. So what am I doing first?
Plugging 0 in for x.
Good. So solve that while I keep crossing it out. Solve it in your head.
Okay. Is it +2?
Yep, good.
Okay.
Now what?
And then you plug the 0 in for y.
Good. Solve that in your head.
-2.
Perfect. So your point, oh, well, look at that. 0, 2. Oh, nice. Negative. Whoops, I did that wrong. 0, 2. My bad. And -2, 0. So it's not as nice as I thought it was. All right, let's see if we can find where they intersect. It seems to me like they're going to intersect
right at like
there.
1 and 3.
1, 3. Now
Yeah.
let's just make sure that 1, 3 actually works in both of them. Plug in 1, 3. Does that work? 1 times 3 is 3 plus 3 is 6.
Yeah.
Yep. And how about 1 times 4 minus
4.
negative 4 times 3? Negative 4 times 3 is negative 12. So what's 4 minus 12?
8.
It's negative 8.
Wait. Oh, yeah. Yeah.
So that works. So that is our solution. So the answer, I'll write it in red, is 1, 3. Okay?
Okay.
All right. Now, again, you could have done this problem by converting it to slope-intercept form. That would have been fine.
Yeah.
If you were going to do that, just to show you, this would become y equals negative 3x plus 6. Not hard at all. This one was a little bit trickier because you'd have to divide both sides by negative 4. So this one would be negative 4y equals negative 4x minus 8. Yeah, I had to subtract that. And now divide both sides by negative 4. Y equals positive 2x plus 2.
Okay.
Okay. So either that, if you're comfortable doing it that way, go for it. But this is not a bad way to do it either.
Yeah.
I call it the cover-up method. Find your 2 intercepts.
Yeah. That method seems a lot easier.
Yeah, they both have their challenges, but neither one of them are terribly difficult. All right. So now they want us to sketch.
Okay.
Sketch graphs with the following solutions. So what would I do for number 5?
For the one solution, wouldn't you just like make it so like you draw 2 lines and then they intersect at one point? So like if you draw a line between like y6 or 6
Yep.
y and like
Yep.
4
See what I did?
Yeah.
You see my screen still?
Yeah.
Okay. How about number 6? What should I do?
You just like draw 2 parallel lines.
Perfect. 2 parallel lines that do not cross each other.
Yeah.
There's no solution. And how about an infinite number of solutions? Here's my first line. What do I do for the second line?
You just like draw it on the same line.
Exactly.
Okay.
Done. All right. Solve the system using substitution or elimination. All right. Well, number 8, they gave you a problem that kind of lends itself to substitution. Do you see how this is y? So we're going to plug it in for that y right there. So I'm going to rewrite the equation, but instead of writing y, instead of writing y plus 2, I'm going to leave a big old set of parentheses there. And now I'm going to plug in what y was equal to, which is 3x minus 1. So this is called substitution, right?
Yeah.
It just lends itself really well to substitution. And now solve this equation. So the first step is to distribute.
Yeah.
The next step is add like terms.
That's what I forgot to do.
And add 2 to the other side, right? What do I get when I add 2 to the other side?
18.
Good. And when that means x equals what?
2.
Good. And now, how do I find y?
You take the bottom equation.
How about
and
the
then
top
you plug
equation? Top equation is easier.
It is.
See how much?
Okay.
See how much easier that is?
Yeah.
Because it's already solved for y.
Yeah. Equals 3.
2, 5 is your solution. And by the way, you can check it by plugging it in to the second equation. Does 2, 5 work? And sure enough, you'll see that it does.
Yeah.
All right. Number 9, we're going to use elimination for number 9. Why is elimination the better one to use for number 9?
I don't know.
Well, they're both in standard form. You see how they're both in standard form? So it wouldn't be easy for me to plug one of them into the other one. I'd have to do some work first. I could do it, but it just wouldn't be that easy. But to convert this to, or to eliminate the y, I'm going to eliminate the y. The reason I'm eliminating the y and not the x, do you know why?
Because it's like, wait, I don't know.
Well, it doesn't really matter, but see how I already have a negative and a positive here?
Yeah.
It's just going to make it easier for me.
Okay.
I don't have to mess with multiplying it by a negative. So I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by 5. And when I do that, look at what will happen. I'm going to have a 15y, and I'm going to have a negative 15y. And then I'm going to add the two equations together, and those will cancel out or be eliminated.
Okay. All right.
Okay? That's what I'm going to do. So here we go. So this equation becomes, make sure you multiply everything by that 3. 9x minus 15y equals 21. Right?
Oh, yeah. Yeah, because you got it.
And what's the next equation going to be?
30x minus.
Nope, not 30.
Oh, sorry. I thought the parentheses was a 1. 10x minus 15y equals 55.
Perfect. So now I'm going to just add them straight down. I've got 19x, the y's are gone, equals 76.
Oh, okay.
Now, I don't know if 19 goes into 76, but I sure hope it does. Hey, look at that, it's 4. So x equals 4. And now if x equals 4, we're going to plug it back into either one of them. The bottom one looks a little bit easier because they're smaller numbers. So I'm plugging that in for x. See how I did that?
Yeah.
So that means 8 plus 3y equals 11, which means y equals 1. 3y equals 3, and y equals 1. So my point is 4 comma 1, and you can check it by plugging 4 and 1 into the top equation and making sure that works. 4 times 3 is 12, minus 5, which is 7. It worked. Notice I don't have to plug it into the bottom one because I used the bottom one to find that second value. So it's obviously going to work in that one. Good?
Yeah.
All right. Mr. Haas went to the movies with a group of friends and bought 3 buckets of popcorn. All right, I'm going to tell you right away. The number of buckets of popcorn, we're going to call that X.
Okay.
And 2 drinks. The number of drinks is going to be called Y.
Okay.
That's just how these work. The next day, they went back to see another movie and bought 2 buckets of popcorn and 3 drinks and spent that much. Well, if the prices didn't change, then we can find the price of popcorn and the price of the drink by using a system of equations. And what we do is to find the variables, let X equal number of buckets of popcorn and let Y equal the number of drinks. So we can write equations for both days.
Yeah.
Day 1, we had 3 buckets of popcorn plus 2 drinks, and that cost a total of $22. See how I came up with that?
Yeah.
So tell me what the second equation is going to be.
Number. 2x plus 3y
Equals
2050.
perfect. Yep. So there's the equations, and then the final step is to solve them. So what's the best way to solve this system of equations?
Elimination.
Good. I'm going to multiply the top by what?
3.
Okay. And what are you going to multiply the bottom by?
2.
How about -2?
Oh yeah. Okay.
Because I want them to be opposites. So that I can just add them straight down. Is that how your teacher does it, or does she have you subtract them straight down? I think the safest way is to make sure the signs are opposite, so you can just add them straight down.
Okay.
That's my suggestion. That way you don't have to mess with the negative in your head so much. You're doing it actually on the work. So what is this this first equation is going to be 9x plus 6y equals 66. What's the second equation going to be?
-4x plus -6y equals 41. -41.
-41. Good. Yeah. And when I add them down, what do I get?
Let me write it down.
5x equals 25.
I think so.
5x equals 25, which means x equals what?
5.
Good. And if x equals 5, how can I find y?
You just plug in 5 to the top equation.
Yeah, let's do it to the top because it looks simpler, right? 3 times 5 plus 2 times y equals 22. So 15 plus 2y equals 22. Subtract 15 from both sides. You're going to get, what, 7? So y equals 7 halves, or $3.50. $3.50. So how much does popcorn cost?
$5.
$5. And how much does drink cost?
$3.50.
Perfect. There you go. That's how you do that system of equations.
Okay. I think there's one more. Oh,
got another one on there?
It's not on there. I forgot to add it. But
yeah,
it
let's do it real quick. Add that real quick, and we'll whip that out.
Oh, that's really blurry. Okay. Oh. Okay. Oh my God. Okay. I just added it.
Okay, the sum of two numbers is -6, and their difference is 16. What are the numbers? All right, so let's call the numbers x and y. So
Okay.
their sum is -6, and their difference, how do I write the difference?
I don't know.
What does the difference mean?
Like how?
Would you be
like,
able to tell me? Did you know that that's the sum? Did you know that? Like, would
wait,
you have been
what?
able to do that?
Oh,
If I
probably not.
said
No.
the sum of the numbers is -6, the sum, that means they add up to -6. And the difference means they subtract to 16. So I would write x minus y equals 16. Okay.
Okay.
So how do I solve this system of equations?
Um.
It's practically screaming at you. Let's just eliminate right away. 2x equals 10, right?
Yeah.
So x equals
5.
5. And then what does y equal? Plug it into one of them. 5 plus y equals -6. So what does y equal?
Wait. Minus 11. -11.
Good, -11. Let's see if that works. Is -11 or is 5 minus -11 equal to 16?
No.
Yeah.
Wouldn't it be -6 though?
No.
Because you have -11.
What's
Oh.
minus a negative?
Yep. Okay.
It works, doesn't it? That means
Yeah.
5 plus 11. So yeah, that works. So your numbers are 5 and -11.
Okay.
Okay.
Yeah.
All right. Practice some more before your test tomorrow.
Yeah, I will.
All right.
All right. Thank you.
See you. Have a good one.
You too.